Hello friends, today we are going to discuss a question based on dynamic programming that is in front of you. This was the question that was asked to me during a client interview recently, and the interview simply gave me a statement that we have been given a floor of size that is n cross m and a tile that of size 1 cross m. We have to calculate the number of ways uh, we can fill the floor with the tiles. So he just gave me a simple input as n is 4 and m is 3, and we can fill it, so the output is 3. So the very immediate step, since this question was very new to me, I asked him, so just a visual representation of how we are getting this 3. So let me clear it. So he simply gave me this explanation that, let's say this is n is 4 and this m is 3. So the size of floor is given, and tile is n is always 1 and m is here 3. So this is the size of tile, we have to fill it. So he said we can put one here, one tile here, please pardon me, I'm not good at drawing, and we can fill all the tiles, or we can put all the tiles vertically, and this will give us one way. Then another way is we can put first tile vertically. Since n is 3, we can put uh, it is not up to scale, but we can put 3 tiles here, so it will fill the tiles. So here width is 1 and here it is 3, so this will make 4 and it is 3 tiles, so m is 3. So this way also we can fill. And another way is just a mirror of this. So this was the third way. So I took a second, or maybe more than a minute, to think with the approach, and then I simply explained it. Okay, we can start filling the flow recursively. That means we'll start with the recursive solution and we'll put the tiles same. We'll try to put first as a vertical, then we'll put it as horizontal, and we'll calculate the number of ways. So let me take another example. The sample test case that they have given, n is 2 and m is 3. Let's draw it. So n is 2 and m is 3. So the floor will look like something, and tile size is m cross 1, so it is 3 cross 1. So tile size will be something like this. So here m is 3, n is 2, and here the width is 1. So we can only put the tile horizontally, we cannot, sorry, vertically. We cannot put it horizontally, because if we are trying to put it horizontally, it will cross the floor, and that's not a valid answer. So let's go to the solution, that how we can put it. So we will simply start with the recursive solution. So I'll write it int get base, and input is int and num. So let me start with the first example that interviewer gave me. So n is 4 and m is 3. So how can I proceed it? I can put the first tile as a horizontally, oh sorry, let me draw it up to scale. And if I am putting it horizontally, so I cannot, the approach is I cannot put any tile vertical here because the size is 1 cross m for the tile. So m and m of for floor is exactly matching. So what we can do is, so if we are putting a tile horizontally, we have to put all the tiles horizontally. And since tile width is unit, so we'll complete it anyhow. So if we are putting the tile as horizontally, the remaining problem will be we have to find whether we are able to fill that floor, the remaining floor or not. If we are able to fill it, we have found a one way. And another approach will be how we can put the tile as vertical. So if we're putting the tile vertically, so we have to find this is one and this is n and this is m. So if we are putting the tile vertically, so we have to find the number of ways or whether we can put or fill the floor, the remaining area of the floor with the tiles or not. If we are able to fill, then we have found another way. So with the same approach, we'll solve it. So I'll just have these two pictures uh, in the screen because those will help me write the solution. So here this tile height is m, or here it is displayed width, and this is my remaining n minus m. So if I am putting my tile as horizontally, so it will take or fill the floor width up to m units and remaining n minus m units. I have to calculate whether I am able to fill it or not. Similar way, if I'm putting it as a vertically, so I have to check whether I am able to recursively fill n minus 1 uh, units of floor or not. If I am able to fill, then I found another way. So using the same approach, we'll write our solution, very naive solution. So the base case will be when we are fill just able to fill up to this point. So when n becomes 0, that is the only case when we are will say that yeah, that is a valid solution. If let's say we are here and we are putting one tile as like this thing, so it is crossing the floor, so that is not a valid answer. So if my n is becoming negative, so I will just say this is not a valid solution. So I will write the base cases with these two uh, statements that we found or that we observed. So if my n is becoming 0, we'll say this is a valid way because I'm able to fill the floor completely. And if n is becoming negative, means that way, that is not a valid way because we are going beyond the floor. So we'll simply return 0, that it is not a valid way. So now we'll try to put the tile, place it as a horizontally. I'll simply rename this name this variable as horizontal, and we'll calculate the gateways. So what parameters we are going to pass is that we have to check from this diagram, like how what variables are changing. So that was the case for horizontal placing a tile, and this was the case for vertical placing of the tile. So if we are placing the tile horizontally, so it will take m space or m width, and it since the tile width is unit, so it will fill it, and we won't be able to fill any of the tile here because it will overflow. So we have to fill it. If I'm putting an first tile as or any tile here as horizontal, we have to fill it all the tiles horizontal, and we have to start filling the remaining. So the recursive call will be, we have to check whether we are able to fill this remaining portion or not. So here the n will become n minus m because we have already filled the m. The same will go n minus m, and m is again constant only, we are not changing it. So this is the number of ways we are getting uh, if we are putting the tile as horizontal, and same will calculate for if we are placing the tile as vertical. So if you are putting my tile as vertical, so the remaining calculation I need to do is for n minus 1. So n minus 1, and m will again remain same. So I will return horizontal plus vertical. So we'll combine both the ways, like just in case the number of ways I got by placing my tile as horizontal, and number of ways I got my tile placing it as vertical. So we'll sum these ways. Here vertical will get 2 and horizontal will get as 1, and we'll submit and return it. So let's try testing it whether we are getting the required result or not. So we'll pass the same parameters nm. In this question it is mentioned that this since inputs can be very large, so we have to take a modulo with this 10 raised to power 9 plus 7 that we'll be writing, but we'll be running this sample solution for sample test cases. We'll see whether it passes or not. Okay, that's great. We're able, it is passing, and I'll run this it with the same input that my interviewer gave, and the output should be 3. Okay, wonderful. We are getting it as 3. So our solution is correct. So let's say try submitting it. I know it won't accept it, but the beauty is we are getting as a TLE. So means there are overlapping sub problems, and we need to optimize our solution for those because we are recalculating it again and again. So we'll analyze how we can optimize it. So if we carefully see in the recursive call, there are 2 parameters that are being used, and only one in any of the recursive call, only one parameter is being changed or altered. Another one is constant. So we need to maintain the states of this one parameter, that is n. So we will create a one dimensional array to store the results. If m was also changing, then we would have created a two-dimensional array. So generally when we create uh, an array or a memory for saving the already computed subproblems result, we'll create it as n plus 1, and we will fill it with minus 1 so that we can know whether this value has been filled or not, and we'll simply pass it with the function. And here we'll see whether this problem before returning it, let's pass it to the same variable to the calling functions, and instead of directly returning it, we will store it then return it. So dp of the only variable changing n, so dp of n will remain as horizontal plus vertical, and then we'll return the same variable. So instead of directly returning the value, we are saving it in our matrix or in the array, and then we are returning it. And before calculating, we will check whether this value has been previously calculated or not. So how we will know? That's why we have initialized it with -1. So this variable's value is, that particular index is -1. That means it is not computed yet, and if it is not -1, so that means this value has been calculated by any of the these recursive calls. So we'll just return it, the same variable. Now let's see whether it runs or not. Hopefully we should not see TLE this time. Oh, okay. So we are getting a wrong input, and if we see, our code is returning minus, the value is in the negative, and its correct output is something else. That is because the ways can be very large, so they have asked us to return the modulo if using this 10 raised to power 9 plus 7. That is just done to maintain the integer overflows or prevent it, and we didn't do it, so we have to take care of that also. So that is very easy. What we will do it, we'll define a constant. I'll name it as a mod, and so I have just written the same 10 raised to power 9 plus 7, and we have to mod it. So where we are summing this way, we're calculating the sum and directly storing it. At this place we have to just take modulus. So by doing that, it will keep our the integer values within this specified range. So this was the only change required. Let's submit it. That is great. It is accepting the solution. Then the very next thing, interviewer will ask, or he said, what are the problems with this approach? Then I said, we are using a recursive call. We are using a recursive function, and it will use a stack, and it might get full, so we'll get a stack overflow. Then he said to further optimize it. Then I suggested him the top-down approach, sorry, bottom-up approach. So in this approach will be, or it is also called as a tabulation. So I get ways to bottom up, sorry. So in this approach, instead of we calculating it recursively, what we will do is we will use a for loop or a nested for loop depending upon the problem statement, and will calculate the result. So here what will we the things will be almost same. We are using a memory. Here also we'll use a memory. The thing was, what we were doing it here, we were calculating by recursion. So when n will become 0, then the last means, if we consider a call like this thing, recursion stack trace. So here n, like let's say n was 4, 3, 2, 1 and 0. Once it becomes 0, it will return the result because our base case would have been hit, and then it will return it same with the horizontal and vertical both. Here we will store or calculate the dp of 1, then we will again, it will return it here. We'll calculate dp of 2, dp of 3 likewise, and will dp of 4. So the matrix will be filled like this way only, but the approach was we had started from ns4, then it went to 3 2 1, and maybe 4 minus, if I'm taking n, let's say 3, so it will be uh, will to calculate with n1 likewise only. So the matrix will always be filled like this. So at last only we will know the result of overall problem. These are all our sub problems. Using sub problems we'll calculate the total problem or complete problem. So in this bottom up approach, what we will do, we'll start with the matrix will be filling in the same order only, but we'll be using a loop. So what we'll do, we will be filling first like dp of 0, then we'll calculate dp of 1 using the previously calculated values, then dp of 2 based on these two values, and likewise up to we'll go dp of n, and that will be our final solution that is required for the problem. So what will happen is the base case that was here, it will become as a before doing that, there are two things we have. Since the thing that was stopping here from the recursion or calculating was calculating the result, that was a base case, so here that part will be converted into a initialization, we call it. Sorry, my keyboard is not very good. Okay, so or maybe I'm not good at with my keyboard. So the recursion, the base condition will be converted into recursion, sorry, initialization part. So here when n is 0, we are returning it as 1. So dp n, so n is like 0, so that point we will be returning it as a 1. So that will be the initialization part, and then we'll compute the problem, or we'll say core dp logic. So here this part will go ahead. So what we are doing is we are actually filling this matrix by calculating it, by getting the results from the recursive calls. So the recursive calls, the result of these recursive calls will be stored into the dp. So we'll be like we are calculating it and storing it into the dp. So for this particular recursive call, like let's say for n whatever values n and m, for this n the result is stored into this, and how we are calculating it by referring it to these two values of gateways. So that will ultimately get the results from dp only, this matrix, because we are returning the same here. So what we'll do, we will try to fill the matrix, and I equals to, again we normally start the loop from 0, but since the 0 part we have already covered, so we'll start it as 1, and it will go up to nth index, because the matrix size is n plus 1. So here we are going to put the same code. I'll just copy and paste it here just for easy reference. So here also we'll define int horizontal equals to gateways. So the result of this particular call will be stored into dp of this matrix alone n. So here if we see, the n is changing, so like it is n minus m, n minus 1, so likewise. So here the changing variable is I, so we'll replace n with I minus m, and int vertical equals to again gateways, so it is like dp of n minus 1, so I minus 1, and we are storing the combined result of these two into current index or current recursive call. So dp of I equals to horizontal plus vertical, and we are returning it. We need not to return it here, we will return it after calculating the result of final problem, that will be dp of n. So we'll just clear it. So but the problem here is we are starting with I1, so that part will be good because I minus 1 cannot go beyond 0, but this part, that is when I minus m, let's say m is 3 or 4 something, so it will go negative, so we have to put a condition there to check it. So what we'll say, I minus m is greater than or equals to 0, then we will calculate the value because the result will be existing, otherwise 0. So now how this 0 is coming, how would we know that we have to store it as a 0? So again, this is hitting this base case, so when my n is 0, so that means I minus 1, I minus m, that is becoming negative, that is equal to m, sorry n. So this, when this value is going negative, so we are returning it as 0. So the same logic, if this value is positive or 0, we will get the value, otherwise we'll return as 0. And the very final thing, we have to sum and calculate the mode to maintain or to prevent the overflow, and we'll just comment it and we'll say return and cross m. Let's again run it for sample input just to check whether there are compilation errors or not, and that is running beautifully, and we'll submit it. Okay, wonderful. So after arriving to that solution, the interviewer was satisfied, and that concluded the coding round mine. Thank you so much for watching this video.